Hello everyone, I'm Ananya from G500 and today I'm going to walk you through my project Capagent. It's all about turning simple image prompts into professional, detailed captions without extra effort from the user. Let's begin with the introduction. Capagent is designed to bridge the gap between what a user says and what they actually want in a caption. You can give it a simple instruction and it will turn that into a professional, context aware caption that's ready to use. These are the key insights from research paper. So firstly, we have understood that our Capagent tool was actually implemented in two stages. So the first stage is upgrading the prompt. So here the user's prompt is upgraded, adding more detail, context, and rules. It even uses tools like Google Lens and Google Search to get extra information from the image. And next is the second stage, that is generating the caption. So here the final caption is generated using AI and vision tools. This includes things like object detection, answering questions about the image, and even understanding the spatial relationships. And next, we come to the key technologies that were used in the paper that were RAG, that is Retrieval Augmented Generation, which learns from the past examples to improve the plan. And next, we have VQA, that is Visual Question Answering. So here it simply answers scene specific questions for detail. Next, we used grounding dyno, which is mainly used for object detection. And then we used depth anything that understands the spatial relationships in the scene. And finally, we have also provided a GitHub link to the Capagent tool. Now let's talk about the scope of the project. The scope covers everything from refining instructions to generating captions with specific constraints like length, tone, and keywords. And coming to the business case, it's useful for marketing, e-commerce, accessibility, and can scale through APIs for multiple industries. This is the user flow, and this is how the end user utilizes our tool. So first we begin with the user input. So user provides an initial image description like describe this image or caption this image. He can also include the tone of the caption that he needs, like describe this image in a funny tone, etc. And he can also limit the size, like describe this image in 10 words, etc. And then we have instruction evolving. This is where the system refines the prompt using various tools like image analysis, metadata, web search, Google Lens, etc. And that is done to get our professional instruction, which is a detailed, context rich prompt. And then finally, the caption generation is done using the AI agents, which generate the caption using the visual tools like VQA, grounding dyno, depth anything, etc. And then we get the final polished caption that is ready to use. This is the architecture diagram. So firstly, the user gives an image along with a very simple caption or instruction. It's usually very short, like just a line describing the image. So next, the system sends that image to Google Lens to find visually similar images online. Then it uses Google Search through something like SERP API to gather extra details about the image. This step helps the system understand the context. Let's just say that a simple random gold car, it actually recognizes it as a Tesla Cybercab. So once we have all that context, we send it along with the user's original input to the MLLM or LLM like GPT-4. So this model grades a simple instruction into a detailed professional one, including things like keywords, sentiment, format, and focus points. So that is actually the professional instruction. Then the cap agent itself comes into the picture. It uses RAG to find similar past examples to guide its thinking and applies the different vision tools like VQA, grounding dyno, depth anything to detect and label objects and to understand the spatial relationships. So finally, it follows a professional instruction and produces a high quality context aware caption that matches exactly what the user needs. This is a workflow of Cap Agent. So firstly, this is the user input. As you can see here, this is the image and also a very simple instruction. And then this is a generated professional instruction. So as you can see, it has several parameters on which the professional instruction is generated. And then this is a chain of thought examples that is done by the Cap Agent. This is the thought one. This is action one. So this is how it, observes and makes changes and gives the perfect output. And this is finally the generated caption. As you can see, it is very detailed and a very professional one, and also gives a lot of context into the picture. So these are the AI models and technologies used in our project. So firstly, GPT-4, it enhances the language understanding and generation. And then there's grounding Dino. This is especially used for object detection. So when you give a particular image and you want to find a particular object, this is a very helpful tool for that. And then there's depth anything that is a tool that helps us understanding the spatial relationships between the objects in an image. And then there's external web search. We're using Google Lens, Meta Search, and all of these things to add to our context. And then there's RAG, which basically enhances planning with past examples. Python is the main language that we're using in our project. And then there's Fast API and cloud platforms that are basically used for their regular purposes. While Capagent already delivers high quality captions from simple prompts, there's still a lot of room to make it even smarter and more versatile, and that is why we plan to expand its capabilities so it can work across more formats, integrate with creative tools, and adapt to specific industries. So the first one is Creative Tool plugin. So we could integrate Capagent directly into tools like Photoshop, Figma, etc. So that way, the designers can generate captions instantly while they work on their visuals. No need to switch between apps. The next one is video captioning. So another goal for us was just to move beyond the static images into videos. Like this would allow Cap Agent to summarize and describe video content, adding the details like timestamps and highlighting important events. And then lastly, we had the idea of domain specific adaptation. Like we want Cap Agent to specialize in different industries like healthcare, e-commerce, or education. This means captions would automatically include the right terminology and tone for each field. So that's all for my presentation. Thank you for listening.